Hey there, Zikal and this is Company 30-day challenge. In the Goldman Sachs questions, today we'll solve the question number 12, which is find total number of squares in an end-to-end chessboard. So we have been given a number, and in which we have to count the total number of squares in the end-to-end board, and we have to return that. So an example is there, like if there is any n equal to 1, then 1 to 1 chessboard will definitely contain 1 square. If there is 2, then there will be 5 squares. So let us see by looking at the example. If there is n equal to 1, then 1 into 1 size will be there, and there will be only one board, one square. If there will be n equal to 2, then 1 2 3 4, okay, and 4 plus 1 is this whole square, which is equal to 5. If there will be n equal to 3, then 1 2 3 4 5 6 7 8 9, and 9 plus 2, this is 1 into 1 size of 9, and this is 2 into 2 size. This one also we have to consider. So this is 9 10 11, this is 12, and this is 13. So 2 into 1 size are there 4, plus 1 into 3 into 3 size, this is whole, this is a 3 into 3 size, so this is also a square. So total 14 squares are there. You can see, 9 plus 5 means 40. 5 is this one, 2 into 2 as 2 into 2, and this is 3 size. So total 5 of previous elements plus current value squares, total 14. And in the 2 into 2 size, 4 of current value square means 2 into 2 plus 1 is previous. You can see every time we are taking the previous value and then we are calculating. So using dp array, we can store the previous value and use that in the current value square. So now let us see the code of that. This is a long type value, so we'll take a long type of array, and in the array, first and 1 into 1 size there will be only one square, and for rest of the elements, for rest of the values, we'll iterate, and in the current value, 1 current value square plus dp of I minus 1 means previous value. As this can be, as you can see here, 10 into 5 constraint is given there, so we have to take a long, and then return the nth value. Let us submit and see if it's satisfying our constraint or not. Oh sorry, let us submit again. So you can see problem solved successfully, but there is one thing you can observe. This is a size order of 1, order of n, and order of n, which is order of n time and order of n auxiliary space. But in the question we are given order of 1 and order of 1. So order of 1 time, order of 1 space. Let us also see, let me show you the other method in which we'll do this by using order of 1 space and order of n time, and then I will show you the order of 1 size and order of 1 time complexity also. So for order of n time and order of 1, what we'll do is we'll don't store, and we'll store it in the value. So long type value will initialize as 0, and if n equal to 1, then we'll return the value 1, because there will be only one square for size 1. And for rest of the element, until it will be greater than 0, what we'll do is in the answer we'll do the same thing as the previous submission we have done. So what we'll do is we'll store the current square and decrement it, and then return the answer, and this will do the same work as the previous. But in the previous case we have been storing the value, but in this case we will not store. So this one time complexity is order of n, as we are traversing through all the elements till n, and space, auxiliary space, is order of 1. Now let us see how we'll solve in the order of 1 time and order of 1 space. So for this you have observed till now. Let us see the example. For n equal to 3, we have these 9 elements. Okay, 9 elements of size 1. Then this 2 into 2 size, 9 square of size 1, and then 2 size, 2 into 2 square. There are 4 squares are there of 2 into 2 size, and only 1 square is there of 3 into 3 size. You can see. So this one is n square, means 3 into 3, and the 2 size are n into 1 and n into 1, means 4. Number of square of size 2 into 2 are 4. So n into 1, n into 1 means 3 minus 1 into 3 minus 1, which is equal to 4. And size 3 into 3 size, there is only 1 square. So 1 square you can say, or 1 same. So you can see it's making a sequence, and the formula of this sequence is, if there is 1 square, then 2 square, 3 square plus n square is summation of 1 to n square. This is 1 to n, and the formula is n into n plus 1 into 2n plus 1 by 6. So we can use this formula in our question, and we can definitely return the value, and this will solve in order of 1 time, order of 1 space only. So let us return. You can see here is formula 2 n into n plus 1 into 2n plus 1, n into n plus 1 into 2n plus 1 by 6, and this will do our work. And we'll store this. Let's make the bracket, and then let us compile and run, and we'll submit that. And this is order of 1 time and order of 1 space only. So we have seen. So we have seen all the 3 codes, all the 3 algorithms. This is order of n time, order of n space using DP array, means we are using the previous value. This is order of 1 n time, order of 1 space, and we are not using the any array extra space, and we are just storing the previous value in the variable. And this is order of 1 time, order of 1 space, which we got using the summation formula, means that was making a sequence. So we made a formula, and we just did it using one formula only. So this was all about the video. If you like that, then hit the subscribe button, and let us meet in the other video for this series.